Good
Hello.
morning, everyone, and welcome to everyone in the class, whether they are online or offline. I hope I'm audible and visible. And with this, we start today's session, today's lecture. Today's lecture is a continuation of what we were doing in the last class. And in the last class, we had introduced a concept of gravitational potential energy. We had also introduced the concept of gravitational field, and we had seen gravitational field is an area where a body can experience gravitational force. Earth is creating gravitational field in all the space around us. We can experience gravitational force because of gravitational field of Earth. This gravitational field also creates something that we call as gravitational potential. Because of this gravitational field, if you take any point, we can say that it has some potential. It has some potential. If I put a mass over there, that potential becomes gravitational potential energy. So everything comes because of the concept of gravitational field and gravitational force. Gravitational field creates gravitational force. Gravitational field creates gravitational potential. And if you have another body kept there, it gets converted into gravitational potential energy. Now we have seen quite a few things about gravitational potential energy. What we are going to do is we are going to note down everything that we know till now about gravitational potential energy point wise, so that will help you in understanding gravitational field if you want to revise it very quickly. I've always told you, while you are making notes, you always note down the points that are very important, mark them. The questions that we are doing, mark those questions, so that while you are revising, you can just look at those questions and you will be able to do your revision quickly. As I've always said, I'm not a very big fan of revisions. Revisions get us into a very bad state of mind, because I understand while you are going for your final exam, you will not have enough time for revision. But everyone wants to revise. So make your notes in such a way that while you are revising it, you can just go through your notes. During revision, there is not a good habit of reading it through a book, because in the book, you might have a lot many things that may not be relevant. Good morning, Guru Prem. That may be not relevant, and it is not advisable from my point of view to revise through a book. It's always advisable to revise through your notes. Your notes are written in your language, and as soon as you see them, you will remember, you will have memories of what was happening in the class. Gravitational potential energy. What is the first point that we must remember about gravitational potential energy? Anyone? What is the first thing that you must remember? You have the mic, and I think it is working today as well. What is the first thing that you must remember about gravitational potential energy? Anyone? Anything that you want to say? What is the first thing that you must remember about gravitational potential energy? Whether it is gravitational potential energy, whether it is electrostatic potential energy, whether it is spring potential energy. What is the first point that must come to your mind when you think about gravitational potential energy or potential energy? Anyone?
Gravitational field.
Just speak loudly.
It creates gravitational field.
I can't hear you clearly.
It creates gravitational field.
Then someone speak louder. I think she's not able to speak louder probably. Bol beta. Try. I'm not able to hear her.
Sir, can you hear?
Your sound is very less. I don't know whether my sound is very less. So what I'll do, I'll increase it. Okay. Now speak.
Are you audible?
Yes. Now you're audible. Speak. I increase my levels of sound. Yes, tell me now.
Sir,
Yes.
it creates gravitational field, sir.
Gravitational potential energy creates gravitational field. Okay, the other way around would be more better. That gravitational potential energy or gravitational potential comes because of gravitational field, and that is the first point that we will write. Gravitational potential energy or potential energy is always associated is always associated is always associated with what? It always associated with conservative forces. Conservative forces, or you can write conservative fields. So wherever you have gravitational field, you will have gravitational potential energy. Wherever you have electrostatic field, you will have electrostatic potential energy. So potential energy, this term, whenever you use this term, it has to do something with conservative forces or fields, conservative fields. That is the first thing that you must remember about potential energy. What is the second point that you must remember about potential energy? What is the second point that you must remember about potential energy? No one? The second point that you must remember about potential energy is absolute value of any type of potential energy. Absolute value of potential energy is not defined. There is no definition of absolute value of potential energy. What is the absolute value of gravitational potential energy? There is no definition. What is the absolute value of electrostatic potential energy? There is no definition. So, whenever you use the term potential energy, you must never associate it with a definite value, because definite value or absolute value is not defined. If something is not defined, it does not exist. Absolute value of gravitational potential energy or electrostatic potential energy is not defined. Then there must be something that is defined. What will be that thing that is defined? What is that thing that is defined? Absolute value is not defined. Then what is defined? And we'll see the definition today, but we'll do the definition at the last rather than doing it at the first, because I have realized that if I give you a definition in the beginning, difficult to understand it. Sometimes becomes difficult to understand it, and it might look very difficult as well. If absolute value of gravitational potential energy is not defined, then what is defined? What is defined? Only the change or difference in potential energy is defined. So the definition only exists for change in energy. How much the energy has changed. The definition only exists for change in energy. That is the only thing that is defined. Now, you must remember, and I must tell you that there is a subtle difference between change and difference in the way that is used in the class in physics, or I am going to use it. Did I tell you the difference between change and difference? Yes or no? What do I call change in energy, and what do I call difference in energies? Change in energy, difference in energy. There's a subtle difference here. What is the difference? Suppose I am going from a point A to a point B. Now I can follow any path. I can go from here to here in path number 1, or I can go from here to here in path number 2. Now, if there is a conservative force, if there is a conservative field, the work done in going from A to B in path 1 or path 2 will be same. We know that Work done in a gravitational field or work done by a gravitational force does not depend on path. So if I'm going from A to B in any path, the work done is going to be same. Now, here my point A, since I'm going from point A to point B, my point A becomes my initial point. It's very simple. Physics is very simple. It uses English terms and it means the same thing. My point A is my initial point and my point B is my final point. So this is initial point, this is final point. If I'm going from B to A, the things will reverse. B will become initial point and A will become final point. It's very simple. A is the initial point, B is the final point. Now, if I call the energy at point A is at UA, remember, energy at point A is not defined. Let us assume that it is defined. If I call energy at point A as UA, and let me call energy at point B as UB. So I hope the scenario is clear. Energy at point A, if I can define it, it is UA. Energy at point B, if I can define it, it is UB. I am going from A to B. A is the initial point, B is the final point. Now, when I say change in energy, so how do I write change in energy? Change in energy, change, remember the word delta, delta U from A to B. That is how I write change. Change meaning delta. Change meaning delta. Delta U A to B. When I write delta U of delta means change. Change in energy from A to B. What do I mean? I always mean the final value, which is UB, minus the initial value, which is UA. This is how change in energy or change in anything is defined. Whenever we are using the term change, we are always subtracting the initial value from the final value. So it is UB minus UA, that would be known as the change. How much the energy has changed. Final value minus initial value, that is what I call as change in energy. Now, if this is change in energy, what would be difference of energy? Again, the scenario is same. I am going from point A to point B. A is the initial point, B is the final point. Change means UB minus UA. What do you think is the meaning of difference? What do you think is the meaning of difference in energies? Can anyone tell me? Difference in energy. Difference in energy. Anyone would like to try? Change in energy is UB minus UA. What would I call as difference in energy? Now, whenever we are using the term difference, what are we going to do is we are subtracting final from the initial quantity. That is how difference is defined. When I'm saying what is the difference between A and B, A minus B is the difference between A and B. A minus B is the difference between A and B. What is the change between A and B? B minus A is the change. That is how subtle difference is there. Change or difference in potential energy is defined. Change is always final minus initial, and difference is always initial minus final. Do we understand this? Can I have some raise hand that we understand this? Okay. Change and difference. So only the change or difference in gravitational or electrostatic potential energy is defined. We are not going to get into electrostatic energy. Here we are going to concentrate our thought process on gravitational potential energy and spring potential energy. So what we are going to do is again write some important points about those two things. I hope you are noting down everything and not making a mistake there. I hope everyone has noted this down. Now, most of the question that you're going to do can be done with the two things that I'm going to tell you, and they are not rocket science that no one will understand. So I'll write point number 4. which is going to come gravitational potential energies. About gravitational potential energy, in most of the cases, the questions that we are going to do, we are going to assume that okay, now I just missed a simple point, so I'll just add it here as point number. I will call this as point number 4, and I will call this one as point number 5. So I'm going to change it. I'm going to change it. I'm going to put 1 point before this. I'm going to rub this off, and I'm going to again write point number 4. What have we done up till now? The change or difference is defined, but sometimes we might need to give absolute value to a point. You might want to give value to a point. Now, to give this value to a point, there must be a 0 somewhere. So that 0 may lie anywhere, but we can assume it to be lying anywhere else. What I mean to say, to define or to give values to potential energy, a point must be taken as reference whose potential energy is taken as 0. Remember, absolute value of potential energy is not defined, but sometimes I might have to give values to different points. How much is the energy of that point? If I want to do that, I must take a point, I must take a reference whose potential energy can be taken as 0. In most cases, the reference point is taken at infinity. Infinity means at a very large distance from the body. But again, if I go so far for 0, things are not going to look very easy when I'm going to solve problems. For example, most of the problems that we are going to solve in this chapter will be of body falling on Earth, body moving on Earth. Now, if I take gravitational energy of Earth at infinity is 0, that is too far a point to make some sense here. So obviously, at infinity, the gravitational energy is definitely 0. We know that. But we don't have to go to infinity. I don't have to go to infinity for finding out 0, because I can assume 0 anywhere. So where are we going to assume 0 for gravitational potential energy? Anyone having any idea? I don't have to go to infinity. Infinity is too far. At infinity, we will find 0, but I don't want to go to infinity. So what we are going to do is, we are going to just make some assumptions. For gravitational potential energy in this chapter, remember, not in the chapter on gravitation, because I think the gravitation chapter is going to start maybe. When gravitational chapter, we cannot take energy on the point Earth as 0, because that creates a lot of complications there. But in this chapter, what we are going to do for gravitational potential energy at ground or the lowest point, we are going to take it as 0. So we are going to shift our origin. The origin or 0 lies at infinity. Infinity is too far. You can't imagine infinity. So instead of taking it at infinity, we are going to put it on the surface of Earth, on ground. That is the best possible scenario. If there is no ground, you can take the lowest point to be your 0 energy level. You can take the lowest point that you find in a problem. If the problem is not happening on ground, there will be questions where bodies are going to move in circle, they are not on ground. So in that case, it is always better to take the lowest point as the zero energy ka point. What I'm going to say here is, what I want to say, for example, this is my ground level. This is my ground level. Then there are two levels. Let us say two bodies are kept here. One body of mass m is kept at a height h above ground, and one body same mass but it is below ground, inside earth maybe. That height or that depth is also h. Now what I want to do here is give values of potential energies at point A and at point B. So I want to give the values at point A and at point B. How much is the value? But you must know that absolute value is not defined. So if I want to give a value, there must be a point whose value can be taken as 0. That point is at infinity. I'm not going to go there that far. So what I'm going to do here is, I'm going to take ground. This is ground. I'm going to take the value of potential energy. In this case, it is gravitational potential energy. Gravitational potential energy on ground is 0. That is the assumption that we are going to take for most of the problems that we are going to do. In case there is no ground, we can obviously take the lowest point. We can also take the highest point. We can take any point as 0, doesn't matter. But if we take any point as 0, then the values of different points will look different. Now, if I take the gravitational potential energy of ground as 0, it is not 0 there, but I'm going to take it. What will be the gravitational potential energy of this point? Point A. What will be the gravitational potential energy of point A? The point which is at a height h above your 0. Your 0 is here. This is at a height h. You may not be knowing it, so I'll tell you the gravitational potential energy of this point becomes plus mgh, positive mgh. On the other hand, the gravitational potential energy of the lowest point, the point which is h distance below your origin or your ground or your 0 reference, the gravitational potential energy of that point becomes minus mgh. So this becomes plus mgh and this becomes minus mgh. And you will find a very astonishing fact in the chapter on gravitation when you are going to do it, that actually in actual practice, gravitational potential energy is never positive, it is always negative. Gravitational potential energy is always negative, it is never positive. And that you will realize in the chapter on gravitation. Now is not the time to understand this. Now what we are going to do is assume that the energy of ground is 0. Anything above ground will be positive. Anything below ground will be negative. Am I clear with this? Now, you will say, sir, why we are taking energy of ground 0? I don't want to take the energy of ground as 0. If you don't want to take energy of ground as 0, no problem. You can take the energy of this point as 0. You can take the energy of this point as 0, not a problem. You can do that. Now, my simple question to you is, if I take the energy of point B as 0, if I take the energy of point B as 0, which I am going to do in red, the energy of this point as 0, what would be the energy of this point and what would be the energy of this point? If I take the energy of point B as 0, instead of ground, I take the energy of point B as 0, what will be the energy of ground and what will be the energy of the highest point, which is point A? Anyone is going to tell me? Is anyone going to tell me that?
Sir,
Yes, beta.
mgh and 2 mgh.
Well done. It is very simple. The energy of the ground then becomes plus mgh, and the energy of the highest point becomes plus 2 times mgh. So as you can see, just because I have taken ground, not taken ground in fact, as my origin, the energy of different points look different, but that doesn't make any difference, that doesn't make any change, because if you find the difference between the 2 points, it always remains same. And difference is what that matters here. Absolute value doesn't matter, because absolute value does not exist. Absolute value does not exist. Absolute value depends on where is your zero. If your zero is at ground, A becomes plus mgh, B becomes minus mgh. If your origin 0 is at point B, ground becomes plus mgh, and the uppermost point becomes plus 2 mgh. Am I clear? Everyone understands this? So I will not force you to take any point as 0. I would always take ground as 0 if there is ground. If there is any lower point, I will again take that lowest point as 0. Things are simpler that way. But remember, the actual point where gravitational potential energy is 0, in most cases, that is at infinity. And the other thing that you must remember, while you will do the chapter on gravitation, that actually gravitational potential energy is never negative, is never positive, is always negative. Either it is negative or it is 0. Positive value of gravitational potential energy is not possible. That was gravitational potential energy that we are discussing. I hope you have noted this thing down. With this small simple explanation, you should be able to solve any problem that is going to come in your JEE Mains. I hope you are noting it down. This was gravitational potential energy, and how and where we are going to take that gravitational potential energy. What will be your reference level? Depending on that reference level, you can have different values of gravitational potential energy at different points. Apart from gravitational potential energy, the second energy that we are going to deal here, I think this is point number 6, is spring potential energy or elastic energy. For spring potential energy, SPE, spring potential energy, at the natural length of the spring, oops, why am I writing M? At the natural length of the spring, natural length, that means no extension, that point, the spring potential energy is taken as 0, where there is no extension. Now the question here is, where actually it is 0, and in this case the answer is same. It is actually 0 at the natural length. It is actually 0 there, and we are also assuming our 0 there. So there is no confusion in this case. Spring potential energy is taken 0 at its actual point, and that actual point is its natural length where there is no extension. Now I'm going to draw a simple diagram. A body of mass m is attached to a spring of spring constant k. This is the natural length. Here extension is 0. I hope everyone can understand this. X is 0. Now I am going to mark two positions here. This is an extension of x, which is in red. Then there is a compression of x, which is in green. So from its natural length, it could be extended or it could be compressed. Let me call the red point as A. Let me call the green point as B. Now the question is, and we are not going to derive it because derivation will not help you at all in any ways. What will be the energy of point A and what will be the energy of point B? I'll give you a minute to think about it. If you know it, it's very good. You can also note down till that time. I'll give you a minute. Tell me what is the energy at point A and what is the energy at point B. Anyone, any idea what will be the energy at point A? What is the energy at point B?
Kx square, sir.
Kx square at point A. What about point B? Okay, I know that you might not know it, so I'll just give you the values. At point A, the gravitational potential energy is half kx square. At point A, it is half kx square plus half kx square.
2a kx.
Okay, what about the point B? What is the elastic potential energy or spring potential energy of point B? Point B is in compression.
Sir, at point B, 2kx square.
No, it is not 2kx square. See, 0 is here. X distance forward, it is plus half kx square. What will be the value? X distance backwards or compression? Anyone?
Sir,
Yes?
minus half k.
The answer should be minus half kx square. Right? That is the answer that comes to our mind, that it should be minus half kx square. We always understand, try to think that, just in case of gravitational energy, above it was positive, so below it was negative. So that makes us think that the answer must be minus half kx square. But you must remember that spring potential energy is not negative ever. It is always positive. So the answer here is also plus half kx squared. So whether it is compression or extension, the spring potential energy does not have a negative value. It always has a positive value. Remember this point? Always remember this. Spring potential energy always has positive value. Whether it is extension or compression, it is always positive. Remember this, do not be confused. Am I clear? Give you a minute to write it down with the diagram. Write down your point. Anyone having any doubt can raise it now. If you can remember these 6 points, I think you can do most of the question that will ever come. The simple question based on simple concepts. Nothing so tough or difficult about these problems that are going to come. I hope everyone noted it down. If you have noted this down, then we'll have to move ahead and understand or write the definition of potential energy. So I will just start that slide.
Sir,
Yes, beta.
sir, for both compression and extension, sign will be positive.
Yes, remember that. We are not going to get into the derivation part. Just remember that it is positive. Can you remember that for me? Beta, can you remember that? For all purposes, for all cases, spring potential energy is always positive. It is never negative. Will you remember that?
Sir.
Okay.
Sir, irrespective of reference frame.
Our reference frame always is the point where the energy is 0, and in this case the energy is 0 at the point where there is no extension.
Okay, sir.
Okay, right? Chalo. Now, since we have understood gravitational potential energy, there are some notes that you must write about them. I will just tell you what to write and then you will follow. The heading was potential energy. The heading has already been there with you. You don't need to write it. Potential energy is defined only for conservative forces. This is point number one. We have already written it. You may not write it. It's already written. In the space occupied by conservative forces, every point is associated with a certain energy, which is called energy of position or potential energy. We have also seen the definition. Potential energy is the energy acquired by a body by virtue of its position. Same point here. Potential energy are of different types: elastic, spring energy, electrostatic, and gravitation. Point already discussed. The only point that you need to note from here in this discussion is what is the definition. Right now, we're not doing the definition. Remember, the only thing that is defined is change, and hence the definition only exists for change. There's the only definition for change in energy, no definition for absolute value. So that is the definition that you will write. And what is the definition? You will write it from this book and then we will discuss it further. The change in gravitational or any potential energy between any 2 points. Whenever I say change, it is always final, final minus initial. So the body is going from point 1 to point 2 in any different path. A is the initial point, B is the final point. Remember that final minus initial is change. The change in potential energy between any 2 points is defined in terms of work done by the associated conservative force, which is path independent. So this potential energy, you can see energy is the capacity to do work. So gravitational potential energy, spring potential energy, electrostatic potential energy, all are associated with work. And that is how they are defined. How they are defined, the change in potential energy is always defined as work done by conservative forces in displacing the particle between these 2 points. So whatever work gravitational force or electrostatic force is doing in moving that body, negative of that work, there is a very important thing that you must remember is this negative sign. The negative of that work is equal to the change in gravitational potential energy. So you will have to note down the entire definition of change in potential energy, whether it is electrostatic, you just add the term electrostatic. If it is gravitational, you just add the term gravitational. If it is spring or elastic, you just add the term elastic, and the definition is absolutely same. A minute to write it, then I'll try to explain it. I hope everyone is writing the definition. Has everyone noted it down? Okay, I think everyone in the class has noted it down. So what is the change in any type of potential energy? So basically what we are assuming here is that a body is moving from point A, which is the initial point, to a point 2, which is the final point. It can move in any path, doesn't matter. Work done by conservative force does not depend on path because it is conservative force. That's the definition of a conservative force. We have also seen that. We have seen that. So how it is defined? So it just simply says that delta U from 1 to 2, point 1 to point 2 is nothing but negative of work done by the conservative force in moving it from 1 to 2. This is the very simple form, the simplest form in which I can write this. Book will not write it like this because for work done they will just use W. I always use delta W. I told you the reason. For change in gravitational energy, they might use delta. So delta U from 1 to 2 is negative of work done by the conservative force in moving the object from point 1 to point 2. Now this work done can be simply written as integral of F dot dr, that is the definition of work done from point R1 to point R2, and you just put a negative sign. That is the definition of work done. We can't change it. It is the way it is. That is one way of writing it. The definition of any potential energy. Remember, only the difference is defined. Not only the change is defined, nothing else. Now this thing can be written in a different way. I can write it. Remember, point A is my initial point, and point 2 is my final point. So I can also write it like this. Change is always U2 minus U1 will be equal to negative of work done by the conservative force in moving it from point 1 to point 2. So the second way is the same way, just written in more elaborate form. So U2 minus U1 is negative of work done from 1 to 2. Or as you can see, there is a negative sign here. You don't want negatives in your life, you can bring the negative sign here. If you bring this negative sign here, how does it look like? Everyone will tell us. So instead of U2 minus U1, it becomes U1 minus U2. So U1 minus U2 now becomes work done from 1 to 2. Now you can remember this definition in any of the three forms and you are good to go. All the three forms mean the same thing. I hope you have understood this, beta. Simple definition. This is just for your academic purpose, but yeah, we'll be needing this in solving problems. If you can remember this, it will be a very good thing. If you can remember in terms of U2 minus U1, you remember it in terms of U2 minus U1. I always remember it in the third form. So I'll tell you my way of remembering it. I always remember it in the third form. This is the form that looks easiest to me. U1 minus U2 is work done from 1 to 2. No negatives. I don't like negatives in my life. So U1 minus U2, that's my way of thinking. My blood group is also positive. Be positive. So always remain positive. I don't use negatives. So I don't use the negative wala term. So I take it as U1 minus U2 is work done from 1 to 2. That is the way I remember it. The green way. Green is a good color. Pink is also a good color. All colors are good. White is also a good color. Black is also good. U1 minus U2 is work done from 1 to 2. This is how I remember it. Easier for me to understand. No negatives. This is the definition of change in potential energy. But as I told you, sometimes we need to what? Sometimes we need to give values to different points. We want to give values to different points. Then we must have a reference. In most cases, that reference is taken as infinity. So we'll now see the second definition where we have taken the reference point and we are going to define absolute value in terms of the reference point. And here it is defined in terms of the reference point. It comes on your screen now. We've written the first definition of change. If I want to define in terms of absolute value, I can't do this, but for that I need a reference. So that is how you define it, and that is how I am going to underline it in red this time so that you understand the difference. If we can define a unique value of potential energy only by assigning some arbitrary value to a fixed point called the reference point. So we must find the reference point. Whenever and wherever possible, we take the reference point at infinity and assume the potential energy to be 0. So when your first position is infinity, you can take the value of potential energy as 0. Then the energy of the other point, we take one point as infinity, we take that energy as 0. So U1, which is the infinite point, becomes 0. So U2 minus U1 simply becomes U2 or simply becomes U, and this is how we can define the absolute values of potential energy at different points. The absolute value of potential energy at any point, assuming that at infinity is 0, is negative of work done. So this is how you can define it if we have a reference point, and that reference point is at infinity, and that point key energy is taken as 0. So this is the red one. Write the red one. Don't need to write the red one, and then you can also where is the eraser. Then you can write it from here till here. In case of conservative forces, potential energy is equal to negative of the work done in shifting the body from reference point to the given position. So this is how you can define it. The red one, you have taken a reference point at infinity as 0, and then you are defining the energy of alag points. This is not required for this chapter, but I am doing it for the next chapter, which is your gravitational. You will be needing it there, not here. I don't need it here, but still we are doing it because you have to study it at some point in time, and if you can understand it in the first case, it becomes easier for you to understand it completely. So I'll give you a minute to write this. Write this. And then we will do a question and probably understand the difference, the meaning of it. I hope everyone is noting it down. Okay, I hope everyone has noted it down. If you noted this down, here comes a small pretty question that is going to help us in understand how they are related and how it comes all together. So I have a block of mass m, simplest possible question, place at a height h. That point I have called A, then the point on ground is called B. What I'm going to do is I'm going to drop this. We've done this question so many times. I'll drop this block. It will obviously fall on ground. The question is not with how much velocity it falls. That is a different question. We'll do it again. Don't worry. Right now, we are concentrating on two questions, number one and number two. Number one is what is the work done by gravity? G standing for gravity from A to B. A is the initial position, B is the final position. What is the work done by gravity in moving it from A to B? Second question in green, no, not in green, in blue is what is the change in the energy from A to B? Two simple questions with two simple answers waiting for your answers. Two simple questions, two simple answers. What is the work done by gravity in moving it from A to B? What is the change in gravitational potential energy when the block moves from A to B? 1 minute.
Let's MGH, sir. Work done by the gravity from A to B.
Work done by gravity from A to B is definitely correct. It has to be plus mgh. No questions asked, no answers given. Everyone knows this. Body is moving from higher position to lower position, so it is positive. Plus mgh. Second question, the blue one. What is the change in gravitational potential energy? So for that matter, what we got to do? Assign value. So what I'll do is I'll assume that the potential energy at this point is 0. So the potential energy of this point becomes how much? Plus mgh. I have to find the change in energy. Change is always energy at point B minus energy at point A, and you will see what is the value of that change. It will come as minus mgh. Do we all understand this?
Yes, sir.
Pretty simple, pretty straightforward. No questions asked, no reasons given. And now you can see the relation between point question number 1 and question number 2. What is the relation that you see? And that is the relation that I want to tell you. What is the relation between A and question number 1 and question number 2? Do you see a relation? Do you see the relation between question number 1 and question number 2? The relation is very simple. The change in energy when the body moves from point A to point B
Work done.
is negative of the work done in moving it from A to B. That was the definition of change in gravitational potential energy, and that is exactly what we have found out when we have done it correctly. Do we understand this? Can I have some raise hand that we understand this? Pakka everyone, well done. Chalo. We have done one question on gravitational potential energy. I think it is pretty evident. We'll do one more question on spring potential energy and we will wind off our class. So do it fast because I think we only have 2 minutes left. 2 minutes is more than enough to solve this question. So I'm going to do it fast. Dun. This is the block of mass m, spring of spring constant k. This is the natural length at this point. Now what I'm going to do is displace it from here to here. As you can see, it is an extension of x at point A. This is, let us say, point B. That was the initial position. Point B, the natural length is the initial position. Point A is the final position. I've just changed the number so that you just understand that A and B doesn't matter. What matters is what is the initial and what is the final. Again, two questions will be coming to you. What is the first question? Number one, since you have not known, since you don't know what is work done by this. So number one question will be change in spring potential energy from B to A. So that is the first question that you will solve. Once you get the value of that, then you should be able to tell me what is the work done from B to A by the spring on the block. Spring is the force, block is the body. What is the change in spring potential energy when the block moves from B to A? And what is the work done? Remember, we did not find out the work done by spring force. I told you I'm not going to do this work done by spring force because I'm going to do it later, and this later is now. Instead of doing it as work done by force, spring force, we are doing it as change in spring potential energy. So what is the answer for the first question? First part. What is the change in spring potential energy? So that will be equal to UA, energy at point A, final point, minus energy at point B. Do we understand this? Yes or no? What will be the value? What is the energy at point A? Plus half kx square. What is the energy at point B? 0. So your answer is change in spring potential energy when I move it from B to A is simply equal to plus half kx square. Do we understand this? Can I have some raise hand that we understand this, sir?
Yes, sir.
Well done. Then if you understand this, and now you know the definition of change in energy without solving anything, can you tell me what is the work done by spring on the block? Block has moved from B to A. What is the work done by the spring on the block? You don't know how to find out the work done, but you know the process. You know the concept, how you will find out. Can anyone tell me what will the work done?
Square
That will be equal to, oops, wrong color. That will be equal to
minus half kx square.
minus half kx square. And this is what you need to understand. The relation, if you understand the definition, then only you will be able to understand the relation. If you don't understand the definition correctly, the relation is gone and you are going to lose precious marks there. If you understood this, congratulations, and you are well equipped to solve any problem in potential energy. We'll be doing the problem in the next class. Don't worry about. Yes, beta. Any doubt? If there's any doubt, you ask me. I'm always here. The class winds off here. We have seen the definition of gravitational potential energy. We have seen the definition of change in gravitational potential energy. We have seen how to apply it in problems. Next class, we'll be doing more problems. Until that time, if you have any doubts, please ask. I'm here. The class from my end is over, and it's good that all of you are participating. That is how things are done. Without participation, the class is a useless class. Whether I take it or Lord Krishna takes it, doesn't make any difference. But yeah, if you participate, there's anyone who is taking the class, it will be a good class and you will understand things. On that note, I will wind off today's class. Any doubt, ask me. Else, have a good day. Keep studying. We'll come back with questions in the next class. Take care, everyone.